Hey guys, welcome to our week 1 video 2 notes. So I just want to take a couple minutes before we get started on these to remind you that you can find these notes online on Edmodo. If you go into the assignment for the week 1 video 2 homework, you will see both the homework in there and you'll see the notes in there. So if you would like, you can print these notes off and you can follow along with me that way. If you would like to just do your notes on normal notebook paper or in your math notebooks, that's also okay as well. It just would have to be that you'd have to draw a couple of extra pictures. So it's kind of up to you what you guys want to do. I know that the first video and our first kind of like homework assignment was a little bit confusing just because it was something that we hadn't done before. But you guys have done a really awesome job making sure that you have done the video, making sure that you did your homework and submitting it, showing me pictures of you guys holding your homework. So I really appreciate you guys taking the time to do that for me. And I know that it's a little bit strange just because it's kind of the first time that we've done something like this, but the more that we kind of do this, the more we're gonna practice, the more comfortable you're going to feel, and the better it's gonna be for you guys as we kind of go on. So as we continue on these couple more weeks, I think you're gonna start to get a little bit more into like a habit and understand what kind of is expected of you and how to submit things, and so on and so forth. So what we're gonna make sure that we do is every time you're gonna submit all of your homework to me on Edmodo from now on, we're only going to use Microsoft Teams for attendance and nothing else. Okay, so we're going to get ourselves started on our week 1 video 2 notes, which is section 11.2, volume of prisms and cylinders. Okay, so in order to do our volume problems, before we can do volume of prisms and cylinders, which are 3D shapes, the first thing we're going to do is we're going to take some look at some 2D shapes. And we're going to make sure that we have a little bit of review of finding the area of some 2D shapes and circumference. So if it's a 2D shape, that means something that is flat, right? So like this piece of paper would be 2D because it is a flat, it's like a flat surface, right? 3D is something that like holds volume. So for example, a 3D shape would be something like this really fabulous balloon that Miss Damaso has. Ooh, see that balloon? Look how great this is. All the things inside of the balloon. The other day was my birthday, so this is what Miss Damaso has left over. Some really fun balloons. Okay, so that would be a 3D shape. Volume would be how much can be held in that balloon. 2D shapes are going to be area, things that are flat surfaces. Okay. So the first one is parallelograms, squares, and rectangles. I'm sure you probably remember this, but in order to find the area of any of these 3 shapes, we're just going to do the base times the height, or you might also see it as length times the width. So if we're going to find the area of this parallelogram here, we're going to look for the base, and then we're going to look for the height. Now, anytime you're looking for height, you want to make sure that it's always vertical. Right? So vertical means straight up and down. So if you're saying like, you know, Miss Damaso's 5'6", that's how tall I am vertically. It's not my slanted height, it's my straight up and down height. So for this parallelogram here, my height would be 16.1. And then the base is just where your parallelogram sits. So it's at the bottom here. This would be my base. Okay, so my area is equal to base times height. My base is 11.8 times my height is 16.1. And when I put that into my calculator, I get area equals 189.98. And now it's meters, right, because that's the label, and then it's meters squared. Now, it is squared because it is a 2D shape. Okay, and anytime you do area, it's always going to be a unit squared. Okay, so if I ever ask you for the area of something, you're always going to say meters squared, inches squared, centimeters squared, whatever. Okay, that's the first one. Easy enough. All right, second section is triangles. So triangles are almost exactly the same as the parallelograms. You're still going to do base times height, but once you do that, you're just going to divide it by 2. Okay, so base is where it sits, so my base for this problem would be 15. Height, again, would be the vertical up and down, and you can always look for it because it's going to have the little 90 degrees right angle next to it. Okay, so because this has the 90 degrees, this line that goes along with it, the height is 21.3. Okay. So essentially I'm just substituting into this equation here. Area equals 15 times my height is 21.3. Okay, and I just put that into my calculator. Oh, excuse me, I forgot the most important part, didn't I? Base times height, and then I have to divide it by 2. Whoops, apologize there. Okay, so if I multiply these two numbers together on the top, I'm gonna get 319.5, and then I just take that number and I divide it by 2. So my area for this problem is 159.75, and again, it's area, so it's meters squared. It's a 2D figure, so my units are in squared. Okay, so it's just like the last one, just like a parallelogram, except I'm just taking the number, dividing it by 2. Okay, circles. All right, to find the area of a circle, we're going to do pi times the radius squared. Circumference means the distance around the circle. Okay, so area would be everything on the inside. Circumference is almost like the perimeter of the circle. It's the distance around the circle. Now, there's a couple things to note. Radius is just from the center to one edge of the circle. Diameter is a line that goes all the way through the entire circle through that center point there. So it's important that you can see that in the picture, okay? So I know that my diameter of this picture, of this circle, is 26. To find the radius, I need half of the diameter. So I'm going to take 26 and I'm just going to divide it by 2. So my radius is going to give me 13. And that's important because I need that to find the area. So my area is pi times radius squared. So I know my radius is 13. I'm going to plug that in. Okay, now I have to do order of operations here, right? So before I try to multiply pi times 13, I have to do exponents first. So I have to do 13 squared before I can multiply it. So if I do 13 squared, I get 13 times 13 is 169. Then from here in my calculator, I'm just going to do pi times 169. Now it depends what kind of if you're using a calculator, using your phone should have a pi button. You're probably just gonna have to turn your phone to the side. If you've got a calculator that looks like this one, there is an actual pi button. You just click the pi button, okay? And then you would put times whatever the number is that you're looking for. And we're gonna multiply it times 169. If you don't have a pi button on your calculator, then you can just use the number 3.14. That's a close enough number to use, but if you have a pi button, I would prefer that you actually use the pi button because it gives you a more accurate kind of answer here, okay? So our area is 530.93 yards squared. Okay, now, number 4 says, excuse me, find the area of a circle with a circumference of 25.1. Okay, I know the circumference, but in order to do the area, I need to know what the radius is. So in order to do this problem, I have to find my radius. Okay, so I know circumference already. I also know the equation for circumference. So that equation is circumference equals 2 times pi times r. Now, instead of circumference, I'm going to plug in the number I know, 25.1. And then I put in my 2 times my pi times my radius. Well, I don't know what my radius is. That's what I'm trying to solve for. So what I'm essentially going to do is I'm going to solve this like a normal algebra problem. I'm going to get the r all by itself. The first thing I can do is multiply 2 times pi. If you put that into your calculator, you will get 6.28. Okay, so that's this little piece here, times r is my radius. Now, if I want to get the r by itself, I have to get rid of this 6.28. This is multiplication, so the opposite of multiplying would be to divide it. So I divide both sides, right? Because it's an equation, I want to keep it balanced. divide them both by 6.28, cancels over here. If I put this into my calculator, I get about 4. You'll actually get like 3.999, but we'll round it up to be 4. Now, I know the radius, so now I can figure out what the area of my circle is. So my area is equal to pi times radius squared. I'm going to plug in my radius. So I've got pi times 4 squared. And we're going to do order of operations. So I'm going to make sure to do 4 squared first, which gives me 16. And then in my calculator, I'm going to do pi times 16. Okay, so if we do pi times 16, we get about 50.27. We'll round it up. And it is in inches, and it's squared because it's area. Okay, great. So now we've done a little bit of a review of a 2D shape. That's important because these 2D shapes are going to be the bases of our 3D shapes. So they're going to be the base of our prisms or the bases of our cylinders. So some of those shapes that we've talked about in our last video, those 3D shapes. That's why we kind of did this first. Now we're going to go on to our 3D shapes. Okay. Now, the first part up here is a principle. It's kind of like a theorem. It's called Cavalari's principle. It says if you have two 3D solids that have the same height and the same base, their volumes are the same. So essentially what you're going to see here is you see this is a cylinder, right? And it's a straight up and down cylinder. So this is called a right cylinder. Now, if I take the exact same cylinder with the same height and the same base, and I just take it and I lean it over to the side. So it's the same thing, it's just leaning over. The amount of space on the inside doesn't change. The volume of this one and the volume of this one are exactly the same. It's just me taking something and making it lean over, right? So if I have for example here, if I've got my sparkling ice drink, right? Here's my cylinder. It's straight up and down. It can hold so much liquid that's inside of it. If I take this same one and I tilt it to the side, guess what? I'm not adding or subtracting any more liquid to it. The only thing that's happening is it's going from straight up and down to being on a little bit of a slant. So my volumes are going to stay the same for both of these. This one that's straight up and down is called a right 3D shape. This one over here that's tilted is called oblique. Okay, so it's a pretty easy kind of theorem there. All right, now we're going to find some volume first of some prisms. Now, the first type of prism is called a rectangular prism. So that means at the bottom, the base is a rectangle, and at the top is a rectangle, right? Or a cube. A cube would mean that at the bottom is a square, and at the top is a square. In order to find the volume of one of these prisms, I'm going to take the length, the width, and the height of the whole thing, and I'm just going to multiply all three numbers together. Okay, oh, I should probably move it up. Okay, I'm going to take the length times the width times the height, and that will give me the volume of this entire box here. It tells me what's all the way on the inside. So if I take a look at number one, the shape of my base down here is a rectangle, right? So to find the volume, I'm going to do length times width times height of the whole prism. So here is the length of the prism. It's 17. Times the width of the prism at the bottom is 9. Times the height of the whole prism is, right here, it's 24. So it's super easy. All I'm going to do is take those three numbers, I'm going to multiply them together in my calculator. I'm going to do 17 times 9 times 24. When I do that, I get 3,672. And when I label it as centimeters cubed. Now, I label it as cubed because this is a 3D shape, right? And volume is always going to be in a unit cubed. Okay, so that's really important. So area is a unit squared. Volume is a unit cubed. Okay, easy enough. Let's try the next one. Volume equals length times width times height. And notice I'm always going to write out the equation first because I just like to substitute right below, and it makes it very easy for me so I never mess up. Okay. The length of my box here at the bottom would be, here's a length right here, 14. My width is at the bottom here again. It would be a 10. And my height is right here. It's a very small 4.5. Now guess what? If you switched your length and your width from me, if you said that the length was actually 10 and the width was 14, guess what? That's still going to give you the exact same answer. So the cool part here is that all three of these, it doesn't really matter where you plug them in. You're still going to get the same answer all the way across. Okay? So if I multiply all three of these numbers together, I get 630, and it's volume, so it's going to be inches cubed. Okay, easy enough. All you're doing is multiplying. Super easy stuff here. All right, last one. Volume equals length times width times height. So if I'm saying that this kind of rectangle here is my base, here's my length, 8. Here's my width, 12. You could have flip-flopped those. My height of the whole thing is 39. All right, and then I just multiply all three of those numbers in my calculator. So you end up getting 3,744, and I keep my label as feet cubed because it's volume. Okay, so that prism is probably the easiest type. Rectangular or cubed, right? Length times width times height is easy peasy. Now, all other prisms, okay, so remember, a prism means that the top and the bottom are the same shape and they're parallel to each other. All other prisms, are going to have a volume formula that's just a little bit different. It's volume equals big B times H. The big B stands for the area of the base. So that's like that 2D problems that we did in the beginning. H is the height between the bases. So whatever the top and the bottom base are, the height is the side that connects the two pieces that are the same or matching, okay? So for number 4, we're finding the volume of each of the prisms. Now, if I look at this prism here, first thing I want to do is I want to say, okay, what type of prism is this? What shape is at the top and the bottom that is matching? So if I look, I've got two shapes, right? I've got the triangles or I've got the squares. And so I have to determine which one of those is the base. The base is when you've got two that are exactly the same, and only two. I see two triangles at the top and a triangle at the bottom. So that must mean that my base shape is a triangle. This is a triangular prism. Okay. So that is actually the shape, that's my base, right? This is the base. It's a triangle. Okay. So if it helps you, I might suggest highlighting either the bottom or the top. I'm going to highlight my bottom because I think it makes it way easier for me when I go to try to do the volume formula. Okay, so the volume formula is area of the base times the height of the whole prism. Now, if I look at the base, I need to find the area of this base. So I need to find the area of what's highlighted here in yellow. So I have to find the area of a triangle, right? Okay, now, how do you find the area of a triangle? You take the base times the height, and you divide it by 2. Okay, base times the height divided by 2. Now, to figure out what the base and the height is of this picture is you're always going to look for the right angle. The right angle is going to be on the base and the height. So height has to be a straight line, straight up and down, right? Here's my height, right? Because it makes a 90-degree angle. My height is 7.3. But now I have to figure out what the base is. Now the base is the other side that goes along with the right angle. Now I don't have a number here, but I do see a number in the same position if I go straight up. Right, here's the top. So here's the bottom. If I look at the top in the same position, this number here is 12. So my base of this triangle is 12. My height of this triangle is 7.3. So I'm going to do base times height. I'm going to divide it by 2. Okay, when I multiply these two together, I get 87.6. And I divide it by 2. So the area of my big base is 43.8. That's just this highlighted triangle. Now, I have to take the area of this base and multiply it times the height of the whole prism. The height of the whole prism is whichever side length connects your two bases together. So this bottom triangle and this top triangle, the side that connects this triangle and the bottom triangle here is not the 10, it's not the 9, it's actually the 5. So sometimes you're going to get extra information that you don't really need to use. So be careful that you're doing the right one, okay? So my volume is big B, area of the base, times the height. Well, I know my area of the base. It's 43.8. I know my height. It's 5. When I multiply those two together, I get 219, and it's feet cubed because it is volume. It's a 3D shape. Okay, I hope that one made sense. I know that one's a little tricky when they've got the triangles, but let's do a couple more. All right, number 5. So if you look at this one, you say, okay, which shape is my base? So you need 2 of the same shape. Now I've got a rectangle, a rectangle, a rectangle. That's 3 rectangles, and I've got 2 triangles. That means my base is a triangle. Now, don't be fooled because it's essentially the same thing as this one right above it. It just fell over on its side. So instead of it being straight up and down like this, now it's whoop on its side like that, okay? So I'm gonna highlight you can either highlight the top, the bottom, it doesn't matter, but I'm gonna highlight one of my triangles. Okay. Now, volume equals area of the base times the height. Okay, I know my base is a triangle. To find the area of a triangle, I do base times height divided by 2. Now to find the base and the height, you look for the numbers that go along with the 90 degrees. Here's my 90 degrees. It goes here and here. The 2 numbers that go with it are your base and your height. So here's your base, here's your height. 11 and 5.4. I'm going to multiply them together, then I'm going to divide by 2. So I multiply these 2 on top, I get 59.4, and I divide that by 2. I get my big B, area of the big base is 29.7. The height of the whole thing is what connects this triangle to this triangle. So it either would have to be this line, or this line. Only one of them has a number. It's 16. Now I take those 2 numbers and I plug them into the volume formula. So for my big B, I plug in 29.7 times my height is 16. So my final answer is 475.2 millimeters cubed. Again, because it's volume. All right, hopefully that's making a little more sense. So now let's do one more that looks exactly the same, right? I know which one's my base because it has to be two of the same shape. Well, it looks to me like that shape is a triangle. There's my base. So my base is a triangle. Great. Volume equals big B times H. Big B means the area of your base. The area of my base is a triangle, so it's base times height divided by 2. Now, I've got a little bit of a problem here. If I look at this triangle, I've got this number 32.5. I don't have any two numbers over here. However, I know that this shape and this shape are exactly the same. If this number is 28, well then this number must be 28, right? But now I've got a little bit of a problem because I don't have this number. So now I'm trying to find one of the side lengths, right? So if I were to redraw that triangle right over here, it's a right triangle. This side is 28, this side is 32.5, and this side is my unknown. Now, when you have a right triangle and you are trying to solve for an unknown side length, you are allowed to use the Pythagorean theorem, right? A squared plus B squared equals C squared. A and B are the legs. C is your hypotenuse. It's the one across from the 90. So my C value is going to be 32.5. So I'm going to say I don't know my A value. I know my B value is 28. And I know my C value is 32.5. Now we're going to square some numbers. We're going to do order of operations. 28 squared is 784. 32.5 squared is 1056.25. Now I want to get A by itself, so I'm going to subtract 784 from both sides. I get A squared equals 272.25. Now I want to get A by itself, so I'm going to take that A, I'm going to square root it. It's the opposite of squaring something. Now, if you're using a calculator like this, you're going to push second square root. If you're doing it on your phone, unfortunately I can't show you because I'm videotaping myself with my phone, you want to look for the square root that's got a little 2 inside of it. Okay, so that's if you're using your phone. Okay, you're going to have to put the number first, and then you're going to push the square root button. If you're doing it on a calculator, do just the opposite. You push the square root button first, and then you push 272.25. Okay, and you will get A is equal to 16.5. So this side down here is 16.5, which means this side down here is 16.5. All right, now I did all that work and I can finally find the area of this triangle. So the base is the number I just found, 16.5. The height of this triangle, right, it goes along with the 90 degree, so it's 28. And then I divide it by 2. If I multiply these two on top, I get 462. And if I divide that by 2, I get 231. The height of the whole prism is the part that connects my two triangles together. So either this line, or this line. Only one of them has a number. So my height is 31. Now my final step is I'm going to plug in my area of the base and my height. So I've got 231 times my height is 31. And if I multiply that, I get a very big number. I get 7,161, and my label is kilometers cubed, right, because it's volume. Okay, nicely done. We're done with prisms. Now we're gonna move on to cylinders. Okay, now to find the volume of a cylinder, it's essentially the same thing. We're finding the area of the base and multiplying it times the height, but in order to find the area of the base of a cylinder, it's a circle. So to find the area of a circle, we do pi r squared, and then we multiply it times the height. Don't forget that r stands for radius and h stands for the height of the whole thing. It's what connects the two circles together. All right, so in my first problem here, I can already see my radius is 18. My height connects the circles together. It's 15. So this one's very easy because all I have to do is plug this into my calculator. Okay, so I'm going to do volume equals pi times r squared times h. I just plug in some numbers now. So I keep pi, right, because pi is a number, 3.14. For radius, I plug in 18 and I square it. And for the height, I plug in 15. Now, order of operations says first thing I do is the exponent. So I need to do 18 squared means 18 times 18. I get 324. Now, from here, I'm going to multiply these two numbers together. Okay, or you can put this whole thing in your calculator. It's up to you. I like to break it down a little bit. So if I multiply these two numbers together, I get 4,860. And now I'm going to take that number and I'm going to multiply it times pi. So again, you can push the pi button first and then times that number. You can do the number first, then times pi. I'd prefer you to use the pi button, but if you don't have a pi button on your phone or calculator, you can use 3.14. Okay? So my final volume is 15,268.14, and it's inches cubed because it's volume. So I would venture to say cylinders are probably a little bit easier than the prisms we just did. All right, so let's do one more. Now, oh my goodness, I'm sorry, I've been sitting on my foot, I fell asleep. Okay, so I need to figure out what the radius is, I need to figure out the height. Now don't let it fool you, it's a cylinder, but it's just been pushed over to the side, right? So it's like a can. I know I keep showing you my drink here, right? So it's a can where it's got the circle at the top, circle at the bottom, and instead of it being straight up and down, I move it over to the side like this, right? This height is still from the circle to the bottom circle, except now it's just been tilted over to the side. So my height for this problem is 21. Don't let that fool you. Now, to find the radius is just from the center to one side. However, this number right here is actually your diameter, right? Diameter is all the way across. To find the radius, I need to take my diameter and divide it by 2. So if I take 11, I divide it by 2, I get 5.5. Okay, now I've got my height. I've got my radius. We're going to plug it into the volume formula. Okay, so instead of R, I'm going to plug in 5.5 squared times the height is 21. Order of operations says the first thing I do is the exponent. So 5.5 squared is 30.25. And then just like the last problem, I'm going to multiply these two numbers together first. So I get pi times, and when I multiply those two, I get 635.25. And then in my calculator, I'm just going to put this times pi, or pi times that number. And I'm going to use the pi symbol, and I end up getting 1,995.7, and it's meters, and it's cubed because it's volume. All right, nicely done. Okay, last two problems. We're gonna kind of take everything we just learned and we're gonna apply it to a application problem. Okay, number 9. A cylinder with a 2 centimeter diameter is drilled through a triangular prism shown on the left. Find the volume of the prism. So I've got like a prism here, the triangle prism. It almost is like a cheese block. And I take that cheese block and I drill an open hole through it. So I'm going to find the volume of the prism. I'm going to find the volume of this cylinder. And then I'm going to subtract those two numbers from each other to figure out what's left over. Okay. So this prism's got a triangle at the top and a triangle at the bottom. I'm going to highlight it. Here's my triangle. So I know it's a triangle and a triangle, so it's a triangular prism. Okay, so the first one I'm going to do is just the prism. Now, to find the volume of a prism, it's area of the base, big B, times H. Now, my big B is a triangle, so that's base times height divided by 2. Now, it's hard to tell, but there is like a little 90-degree right over here. That means one of these is the base, one of these is the height. Look at that, they're both 5. So I've got 5 for the base times 5 for the height, and then I divide it by 2. So 25 divided by 2 gives me 12.5. The height of the whole prism connects the triangle to the triangle. That would be this one right here, 14. Okay, so my volume is big B times H. So my volume is 12.5 times 14. So if I multiply those together, I get that the volume of the prism is 175 centimeters cubed. Okay. That's just the prism. Now I'm going to find the volume of the cylinder. Okay, so here's my cylinder that I'm now going to find the volume of. Okay, so cylinder volume is pi times radius squared times the height. Now, if I look at the picture, I can't really tell what the radius is, but if I read the question, it tells me that it has a 2 centimeter diameter. Now, remember, diameter is 2, but to find the radius, I take that 2 and I divide it by 2. I take half of it. Half of 2 is 1. So my radius is just 1. Height of the whole cylinder connects circle to the circle. It happens to be the same height as the prism. It's 14. Okay, so order of operations says I do exponents first. 1 squared is 1, and 1 times 14 is just 14. Then I plug it into my calculator. I do pi times 14. I get that the volume of the cylinder is 43.98 centimeters cubed. Okay, so I have the prism, I have the cylinder that's drilled out from it. So now my final step to find the volume of the whole thing, I'm going to take the volume of the prism and subtract the volume of the cylinder. So my prism was 175 minus my cylinder was 43.98. So the total volume ends up being 131 0.02, and then it's centimeters cubed. And there's my final answer. So essentially I found the volume of the prism, found the volume of the cylinder that was cut out, okay, did both of them, and then I just subtracted the prism minus the cylinder. Okay, last problem. A diagram of Miss Damasa's pool is shown on the left. She plans to fill her pool to a depth of 4 feet with a garden hose that has an 80 foot cubed per hour flow rate. How many hours will it take to fill the pool? Okay, first thing I see is I'm given this whole thing is 27. 27 is my diameter. I know I need the radius. So to find the radius, I take 27 and I divide it by 2. I end up getting 13.5. Let's find the full volume of this cylinder. So I know volume of a cylinder is pi times r squared times h. So I've got pi. My radius is 13.5 squared. Now, I know the height is 4.5 feet, but I only want to fill my pool to a depth of 4 feet. So I don't want to fill my pool all the way to the top. I want to just go and leave myself a little bit of space here at the top. So my height is really going to be a 4. Then I just go through and I'm solving this problem here. So order of operations says I do the 13.5 squared first. So if you square that, you will get 182.25. And then I'm going to multiply that by the number 4, right? Remember I told you guys I like to multiply these two first before I multiply them by pi. So I get pi times, oh, I guess I should do that. That would help. 182.25. Okay, pi times 729. So now I'm going to take the 729, I'm going to multiply it times pi. I get that the volume of my pool is 2,290.22 feet cubed. Now that's great, but it asks me how many hours will it take to fill the pool. Well, I know that it takes 80 feet cubed per hour. So if I take this number and I divide it by 80 feet cubed, it will tell me how many hours it takes for it to fill up. So I'm going to take this number and divide it by 80. And you will end up getting that it takes about 28.63 hours. Okay, now we are finished with our week 1 video 2 notes. You will now go online to Edmodo and you will find that there are some practice problem questions for you to complete. You may complete them by printing it off of Edmodo, or because if you have a printer at home, you can do that. If you do not have a printer at home, you can do the practice problems directly on a piece of paper. You are going to take a picture of your homework and you're going to turn it in to me. And you're going to take 2 different pictures. One picture is going to be with your face and your work, and you will submit that picture so I know it's your own. And then you will also submit a second picture of just the work itself so I can kind of see it a little bit clearer and give you a grade for it. So it's going to look like this if you go online to view it. Give me a second here. Looks like this. It says week 1 video 2 homework. There are 4 volume problems on the front side, on the first page, and then on the second page there are 3 more volume ones, and then there are 3 kind of word problem problems. So in total you will have 10 different problems that you're going to complete for me. Okay, so you're going to submit those online on Edmodo. Please make sure you submit it in the assignment and do not submit it as a message to me, because that makes it way too difficult for me to figure out. Okay, so please make sure you submit it in Edmodo in the assignment listed as week 1 video 2 notes. Okay, thanks so much for watching.